So welcome to the video lecture series on design of pushdown automata. In today's video lecture, we will be designing a pushdown automata for this specific pattern a to the power of n, b to the power of 3n, a to the power of m, and b to the power of 3m, where n and m may be same or may not be same. Now see here, because there are it is actually two conditions are applied. N should be greater than or equal to 1 and m should be greater than or equal to 0, because n and m value is not dependent on each other. Now what we are going to do here is, now as far as when we receive this first part of A, okay, first part of A will be actually received in two parts. First part of A is here, that is a to the power of n. Now we want to equalize this A to B, that is B is actually 3 times more than this A, okay, a to the power of n and b to the power of 3n is there. So as so when I get A, we will be standing in the same state called as Q1, and we will be making 3 A's pushed inside stack. That means for every 1 A, we will be pushing 3 A's inside the stack. Let us assume that we stand in a state called as Q1. Now let us assume this is called as an initial state. Now by default, the topmost symbol of the stack initially it is called as Z0. So we will be standing in the same state called as Q1. When we receive input A, topmost symbol is Z0. We want to equalize this number of A's with the number of B's. That means for every 1 A, we will be pushing 3 A's inside the stack. So the input will be, now stack symbol will be AA Z0. Now let us assume that n is equal to 3 here. Okay. Now once again you will be getting A as an input, but what will be the topmost symbol of the stack now? Topmost symbol of the stack will be A here, isn't it? Now so for every 1 A, so when the topmost symbol is A, we have to keep this A as it is, and apart from that we have to push 3 A's, isn't it? That means there should be 4 A's now inside the stack. Now, as far as we receive A's here, we will be standing in the same state called as Q1. Now, when we receive B, okay, when we receive B, so this will be getting repeated multiple times. When we receive B, we will be changing the state from Q1 to Q2. So, I just change from the state from Q1 to Q2. Now, when we receive B, we have to pop A from the stack. So, now see, when I receive B and topmost symbol is A, I have to pop A from the stack. Now, as far as we receive B, we will be standing in Q2 itself. So, now we will just make a self loop here. When we receive B, topmost symbol is A, we will be eliminating the A, popping the A from the stack. Now, this keeps on repeating until B is there. So, now we are focusing on this part has been done in Q1 itself. Now, when we receive the first B, we are making a move from Q1 to Q2. Now, when we are receiving all these B's, okay, we will be standing in Q2 itself, okay, and we will be popping A's here. Now, when we receive A, okay, in Q2 as an input, now we will be changing the state to Q3, okay. When we receive A and topmost symbol is Z0, that means number of B's will be equal to number of A. Now, when we receive A and topmost symbol is Z0, okay, we will keep this Z0 and we will push 3 A's inside the stack. So, AA Z0. Now, you go to Q3. Now, as far as in Q3, as far as we receive A's here, we will be standing in Q3 itself. So, now input is A, topmost symbol is A. Now, for you have to keep this A, and apart from that, we have to push 3 more A's. So, there will be 4 A's inside the stack. Q3. Now, this goes like this. Now, as far as we receive A, we will be standing in Q3 itself. But when we receive, okay, but when we receive B, when we receive first B, we are making from Q3 to Q4. You go to Q4 here. So, when we receive B, topmost symbol is A. Now, make a transition. Okay, pop the A now. Now, as far as B is, we are receiving B, we will be standing in Q4 itself. So, we will be standing in Q4 itself. So, B and A will be standing in Q4. Now, when all A's are popped now, what will be the topmost symbol of the stack? The topmost symbol of the stack will be Z0. Okay, so in Q4 to Q5, we will make Q5 as a final state. Now, when topmost symbol is epsilon and when we have z naught, we go to the final state. But this is a peculiar case. Imagine that when m value is equal to 0, m value is equal to 0. When m value is equal to 0, now we have 0 number of a's here and 0 number of a's here. So let us assume that n value is 2. Let us assume that if n value is 2 and m value is 0, because m value can be also equivalent to 0, isn't it? In that case, you will be getting AA, BB, B, 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 and when m value is 0, obviously you will get an epsilon here. Okay, nothing will be on the second part. A and B will be 0. Okay, now the first part, this part actually ends in Q3, but in Q3, okay, first that means A, B, B. Actually, this ends in this part. Okay, in Q2, this ends here. Okay, but if you are not getting any A's here on the third part, that means if it is epsilon, now there is no other go for this. Say for example, in Q2, when I get an epsilon, when the topmost symbol is Z naught, okay, that means second part of A's, you are not receiving this part at all. In that case, if you receive an epsilon, you will be standing in Q2. So from Q2 to Q5, okay, when input is epsilon, topmost symbol is Z naught, replace Z naught by epsilon. So this is the perfect push down automata diagram for this specific pattern. Okay, now we will parse a string. We will parse a string for this. Okay, now how to parse a string for this? Okay, we will simulate this for a to the power of, we'll simulate this for a to the power of 1, and okay, I will just use some other colors here. Okay, now we will take A is A, B, B, and we have epsilon. Okay, so that is when n a value is, sorry, when n value is 1 and m value is 0. So what will be the string you will be getting? A, B, B you will be getting. Okay, now we have to apply this for this push down automata. Now what is the string now? Delta of, initially we start from Q1. What is the input string we are having? A, B, B. Now topmost symbol is Z naught. Okay, now when input is A, we stand in Q1. Okay, what do we have to do? When input is A, we stand in Q1. So we go to Q1 itself. We go to Q1 itself. So delta of Q1. So this A goes off, and apart from that, we will be pushing 3 A's inside the stack. So we have B, 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 Z naught, A, Z naught. 3 A's are pushed inside the stack. Now when input is B, topmost symbol is Q1. Sorry, input is B, topmost symbol is A, we stand in Q1. So in Q1, when input is B, topmost symbol is A, we go to Q2. So now, so delta of Q2, now this B goes off, you have BB, AA, Z naught. Okay, now we stand in Q2 now. In Q2, when input is B, topmost symbol is A. So again, we'll stand in Q2. So delta of Q2, and this B and this A goes off. We have B, A, Z naught. Okay. Now, when input is B, topmost symbol is A. So delta of, again we'll stand in Q2. Now this B goes off, we'll get epsilon, and this A goes off, we'll be having Z naught. Now we stand in Q2 now. When input is epsilon, okay, we have to move to final state. Okay, so Q2, when input is epsilon, topmost symbol is Z naught, you replace Z naught and go to your final state. So now we go to a final state called as Q5. Input is epsilon, topmost symbol is also epsilon. So now the string is getting accepted. Okay. So this is the way of designing a push down automata. So due to the space constraints, I have not done the tracing scenario here. Okay. So thanks for watching the video. Have a good day.